Hello everyone, my name is Dr. Jawad Fatai. I'm working with a bunch of smart people at Sun Lab, and we are responsible on making HEMSC controller who is responsible for communicating with the off-the-shelf HEMSC available currently in the customer agent CA. Today I'm presenting this one on behalf of our team, and the presentation consists of physical configuration, firmware configuration, and a live demo over the system plus algorithm. HEMSC controller, which is Raspberry Pi number 1, communicate with the CA, which is Raspberry Pi number 2, and as you see in this snapshot, they are communicating via switch, and HEMSC controller number 1 communicate with the Energate server using Wi-Fi, and Energate server communicate with the smart appliances to control them. So this intelligence inside the HEMSC controller is taking the DR request, digest those things. After evaluating and rescheduling, we are going to manage the smart appliances. How we are doing that one later on in next slides. Bear with me. The firmware structure is been designed to work like object-oriented platform in 4 different layers. First layer is the layer of connectivity and communication, which take care of communicating between all other layers and physical hardware and devices in the network. On the other hand, it makes a network and data firewall to protect the security and privacy of the customer. It sends a limited data to the CA in order to perform fundamental requirements of demand response using the SEP2 or Smart Energy Profile function sets. The second layer is the layer of ontology, which has distributed agents model and also the network platform agent. Regardless of the type of agent, all agents can communicate over information exchange bus or IEBE, and this layer is responsible for detecting the presence of the devices in a house and make a query over them and find the model number, the APIs, and launching the monitoring over the discovered devices. With this approach, there is no need to manually identify each device, and all the agents are automatically generated to be monitored and communicate with the hardware device after they were discovered by HEMSC controller. So in this case, in order to be comply with the IEEE 2030, all other standards like SEP or REST4 with different telemetry should translate to SEP2 file, and then we have a translator part also, which is really important to make the system interoperable and scalable in future. In the third layer, we have data management. So the intelligence of the system is here. This layer is responsible to do monitoring and control the algorithm. The algorithm is capable of doing many smart grid applications, including demand reduction. And this is designed to be enabled in future for other applications like price-based management, scheduling, planning, behavior pattern analysis, and load management. And moreover, we have also alarming and notification. The last layer, which is the GUI part, is responsible for make a unique interface between customer and the Great DR project, because sometimes we have different HEMSC solution, they have their own GUI, so we decided to make a GUI to make a unique communicating platform between the project and customers. It consists of all of those functionality like controlling the loads, changing the thermostat, scheduling. It has some sort of intelligence for rescheduling also, and optimization. So this is a web-based interface because we thought it would be really easy if they are using their Chrome or Firefox, and it enables them to use cell phone, desktop, and any type of the operating system. As I mentioned before, we have to make the system scalable and interoperable, and IEEE 2030 is one of the best standards for a smart grid application. It consists of many function sets in the smart energy profile, which is the CIM model or common information model for the smart grid. So among all of those function sets, we are going to use end device control, load shed availability, DR response, DER availability, DER capability, and DER settings. With those function sets and all of these elements and attributes inside those function sets, we are able to perform a transactional demand response without breaching the privacy of the customers. So as you see, those function sets and elements inside those things are not going to disclose the information of the customers to the utility, and also it's not disclosing the utility size to the customers, and this is somehow keeping the security and privacy for both sides. The algorithm for Great DR project would be initiated from TA, which is a transformer agent. If there is a new DR request from the DSO or utility side, or sometimes the local condition for the transformer passes the threshold, then we have a DR request. In this case, we should go to the step 3, and TA or transformer agent initiate a TDR negotiation with the active customer agent. So after that, if there is a response, TA or transformer agent drop CAs who contribute to the DR request more than allocated DR or demand reduction request, and then we have to optimize the load dispatching. Why we are using the optimized load dispatching? Because it's not fair if you contribute demand request equally between customers. Some of those customers are high consumption customer and some of them are not. So it's better to allocate the load reduction in a fair way, and the optimization in this case help us to distribute this DR request to them fairly, and surprisingly you will see the success rate would be better if you do a fair request to the customer. And after that, after allocating the DR request, it's waiting for the response. So, and it goes to step 1 and waiting for new demand. If there is no DR request from DSO or no new transformer condition, so it take a look on negotiation iteration. It should be limited number of negotiation. So we decided to keep the negotiation less than 5. If the negotiation is less than 5, keep continue negotiation. Otherwise, you have to terminate the negotiation and make the flag of DR mandatory equal to 1. At the CA side, CA is just responsible for keeping the firewall and privacy of utility and customer households. So in this case, it's getting the request from TA, validate those things, and pass them to the HEMSC controller. At the other side also is doing same from HEMSC controller to the TA. So at the HEMSC controller side, it's sitting there and waiting for new demand reduction. if there is a demand reduction, a new demand reduction, and in that demand reduction, if the mandatory is not true, which means that you can negotiate, so then the DR request is in the negotiation part, and the HEMSC controller checks the availability of the load reduction for just looking at the PV, battery, or rescheduling the load. If by rescheduling the load or using the PV or battery we be able to reduce the load, then it posts DR availability to the CA and says, okay, this amount of energy is available to contribute. Otherwise, it says I can drop some loads. So this first negotiation goes to the CA and the TA, and if this is more than allocated, so definitely TA drop this customer from the new optimization. If not, based on the new information, it makes a new optimization and start the negotiation number 2. So this algorithm iterate for 5 times to find a better result. Otherwise, if there is no compromise between the TA and HEMSC controller, TA says no, this is completely mandatory, you have to obey this request, and DR mandatory would be true. And as long as this DR mandatory flag is true, HEMSC controller should perform and apply all of those requests comes from the TA. And instead of going through this flow chart, which is consisting of customer comfort and the type of settings, I will show you how the system works in real time. And just note that we have a negotiator which is responsible for negotiation, and main which is responsible for exchanging the DR request. As you see here, we have right now a live demo. This thermostat is one of those thermostat of Energate. So right now the temperature is 24 in this office. I'm going to, the server is run, I'm going to run the main file which is responsible for communicating with the CA and HEMSC and the Energate HEMSC and the negotiator also. So the negotiation is started. If there is a new offer, it passes to this main function. So right now the load number 1 is off, and the load is on this one, and the temperature right now for the cooling is been set to 23, and for heating is been set to 20 degree. So as you see at the server side, it's receiving the post, which is the load shed availability, and also it provides the end device control to the HEMSC solution. As you see here, I'm not sure this is completely clear or not. The target temperature is 23 and the mode is auto, and since we have the temperature is 24 and the mode is on cooling, it says the cooling goes to be on, and for this case we have a bunch of loads which is the switchable loads, and I didn't provide those things on this live demo, but they are in the lab and they are working. As you see here, the system is robustly working, and negotiation is up and running, and at the same time the server is providing the response, and 200 means everything is okay and the response is good. So for GUI part also I can make a demo later on, but I think for today and this presentation is enough, because I think right now is 15 minutes. Thank you for your attention. Talk to you later.